he had such a long bio and such a large list of credentials that I had to spend a long time really picking the ones that I chose to speak. So Peter is the principal at the Maker City Project and the founder at the Gray Area Foundation in San Francisco, which is an art and technology center exploring the intersection between code and art. He was also an executive at Apple for 9 years and worked with the UN General Assembly to apply big data to solve big problems. And he is also presented on the international TED stage. And so it's quite an honor to have him today at Katapult. So please welcome Peter Hirsberg, who's going to explore a new mechanism for a new world.
Thank you. Thanks, Al. You know, earlier today, Al asked us, why did we come here? What was our intention in coming to Katapult? And I realized that I was excited to come here because this is a group that's really interested in how do we accelerate the UN development goals? How do we combine impact with investing? And the question I wanted to explore is, what are the new exponential techniques out there that are new tools in our toolbox that can actually speed up and accelerate the way that people respond to these things, stuff that we actually call mechanisms and new organizing principles beyond, say, what traditional governments or NGOs or charities do. That's why I want to talk about new mechanisms for a new era, or what 2 Nobel Prize winners and a guy who won't even tell us his name reveal about the future of climate change. Now, for me, this is kind of a personal story that begins when I get out of college. This was almost 35, 36 years ago. I was a government major. I went down to D.C., and I was all excited about making change and kind of working in the government. And what I soon began to realize, now remember, when I got out of college, it was the high water mark of Atari. Okay, so I was a gamer. And I began to realize that whatever I was doing, trying to get things done at work, was a little bit like playing a video game where no matter what you did with the controller, it didn't appear to affect what went on the screen, which actually a lot of people in Washington felt like that. And you could argue that much of the populist stuff going on in the world today is because a lot of people feel like that. You know, in tech, we call that a bad user experience. And that's kind of the reason that I went off to the private sector. I went off to Apple. But then, about 10 years ago, with the rise of open data and social media, suddenly I saw you could start having some of these effects again, except where it really mattered. In exponential things like climate change, increasingly, there was almost this despair. People kind of understood we were running out of time, and you had to make more and more change, and the traditional mechanisms, the Davos or the climate accords, weren't quite getting us there. You know, even Al Gore, you could see him in the last climate meetings running between India and the US the EU trying to get something done. If you don't trust me, remember this headline that was in the Wall Street Journal just after Davos this year. Let's see, I'm hitting the word next, and Mr. Slide Person? Maybe you can advance the slide for me. Okay, now this is called a crash. This is what happens when PowerPoint goes down. And it's exactly. And I have to tell you a story. Okay, when we did product introductions at Apple, this happened all the time. I would travel with 2 laptops and have them hooked up because I never trusted anything. Okay, thank you. Back to this Wall Street Journal headline. You probably saw this one recently. At Davos, frustration mounts over climate measures. EU officials, we've been at this game for years, and we still can't preserve the benefits of globalism while meeting our shared obligations in UN development goals. Yuck. Okay, the EU officials did not say yuck, but I didn't make any of the rest of this up. Because at Davos this year, the headline going into Davos was, the global commons cannot protect or heal itself. The policies that we have that preserve the benefits of globalism are somehow limiting its shared obligations. Essentially, there were people in Davos saying, we don't have the mechanisms to bring about change right now. Government can't keep up with kind of complex systems world. Now, normally, this would be a very depressing way to leave before lunch at Katapult. But fortunately, that over the last 10 years, there have been amazing advancements in economics, in system design, behavioral economics that can apply to these. So that's why I want to explore some of that today. So 2007, Hurwitz, Maskin, and Meyerson win the Nobel Prize for mechanism design. Mechanism design is the reverse engineering of economics. You start with the result you want, and you invent a game that make people behave that way. It literally is building a game. And this is typically applied to problems where the free market doesn't work. For example, in climate change, you invent carbon credits and other things that try to get complex groups of people to behave differently. And it was a big breakthrough, but it was usually applied to governments. The theory was if you invented a mechanism, who would deploy it? Had to be the government because we were top down. Don't forget, they won the Nobel Prize in 2007, the year the iPhone came out, the year cloud computing began. So this was based on like 30 years of stuff that came out when we were at peak centrality. And it was a mechanism that was designed to come up with some better decision-making thing. Fortunately, 2 years later, 2009, Elinor Ostrom wins the Nobel Prize for common pool resources. She says, you know what, if you're trying to solve commons problems, it turns out people can self-organize and solve them. And she was an empiricist. She noticed that, like, native peoples in woodlands in Norway or in fisheries would actually self-organize and create a set of rules, and this did not have to come top-down from the government. And she even suggested it could be non-rivalrous. She did work at UCLA on this, and they threw her out. They threw her out because she was working for the Government Institute, and they said, we go into cities and give them top-down planning, and she said, I have a better way, and well, you can't say that here. She also, as a Nobel Prize winner, had an obligation to come up with a new word that was at least 4 syllables long. You have to do that if you win a Nobel Prize, and I'm not going to explain it to you, but she is.
This concept of polycentricity, of enabling both market and governments at multiple scales to interact with community organization so that we have a complex nested system. And it ain't pretty in the sense that it's nice and neat. And many people have tried to get rid of creative solutions that are complex. But society is complex, people are complex. And for us to have simple solutions to complex problems, not a good idea.
Okay, there's the essence of the problem. Governments and big central decision makers like simple decisions. But the world's getting complex, and she came up with all of these ways of you get beyond that. And of course, if you think about the most complex things in our society, they're never centrally controlled. An autonomous vehicle or a robot or a jet fighter absorbing lots of data and making lots of decisions to kind of keep itself going. So Ostrom made an enormous contribution in 2009. Of course, in 2007, there was mechanism design. But it's what came between them that actually fired something up and gives us new tools today and raises great questions. And of course, what came between them was 2008. October 31st, 2008, in fact, because that was the date that Satoshi Nakamoto released the Bitcoin white paper. Now, Satoshi was reacting against a particular crap game, or a game he didn't like, which was the financial crisis and both transaction costs and the fact that there were no ways of really making payments at scale without a trusted party. So he came up with a mechanism widely hailed. And if you heard Charmaine's talk yesterday, what really got Bitcoin going was great mechanism design. And her lament, how many people heard her talk yesterday about blockchain? Well, and her big lament was, the good news is this had mechanism design. The bad news is not a lot of things do. And so what I'm really interested in today, and we're going to talk about, is a foundation that I've been part of, Token Commons Foundation, that is launching a system called Switch that actually is focused on climate change. So Satoshi comes up with this stuff. It turns out if you want to build a mechanism, you have to find a lousy game. Now, Satoshi found one. People were not happy. With the financial system, that was a really good lousy game you could get a crowd to go to work on. I have brought a wonderful, juicy, lousy game with me today to share with you. And this is actually the game of how current incentives in the market approaches things like energy incentives, which we have plenty of in the US and in Europe, though surprisingly not in the rest of the world. So the first thing is, you would think an energy incentive would incent a carbon-free future. But it actually doesn't. What they incent is doing things like building big windmills or putting in solar farms. And so therefore, you get government money to do those, even if they're not connected or they're spinning in the middle of the day. Even worse, it turns out a megawatt made in California in the middle of the day, you can't give it away. But if you put that in India or Jamaica and it displaced diesel, it would be terribly useful. Do we incent that? No, we don't. Why don't? Well, all of these incentives are fragmented. They're not in a global market. They're very local. They even come and go based on things like political will. You can imagine in a market, we discount things. If you can't count them, they come and go. Also, it's pretty opaque. You would think if people kept track of these, because it's like energy and there's real-time data, it flows into a database and goes into something global. After all, Facebook knows what's going on. Surely people who get up and are energy professionals do. But no, it often stays local, and it's even reported manually. There's no universal mechanism, even in the EU, many different mechanisms. And if individuals want to participate in this, it turns out you really can't, or you have to pay a 30% tax to some utility. So this is actually a really wonderful problem to go to work on, and this is what we're at work on. So what I want to do now is share with you things that I've been learning from how the blockchain mechanism design works that you take into consideration in designing something to solve a social problem. Getting back to our intention here today, these are the kind of things I think, as we think through impact mechanisms, we should apply. So I'll apply these to what I'm up to at Switch, but these are general principles. So the first thing is, turns out you need a clear objective function. What are you solving for? This gets back to the fact that in the energy world, we actually are not saying you get more value for reducing carbon, we let you buy hardware. And Eleanor Ostrom, in her principle, said if you're going to have a common pool resource, we have to agree on what we're up to. Secondly, tap into greed. Tap into greed. Now, of course, there's no lack of that in the Bitcoin world, but it was designed in such a way that it made miners go to work, and if you got in early, you did better. So you actually want to do something that if you're going to get people to participate in carbon reduction, if you get in early, you do better. And you even want to do things like make capital go to the parts of the world that are the dirtiest. So that's a key thing. Turns out you have to encourage sharing in the common interest. Why? Well, as we've heard today, crowdsourcing and lots of data in a world of sensors is where it's at. If you can't make all that show up, you don't get anywhere. And also, you want lots of people collaborate on making the smartest system that can do the best predictions about where to put assets, which is to say, if people compete to build AIs and other people can get rich on their investments, that's good. So it has to be a social movement. And then finally, you want to get the winds of exponential change behind you. Like if you add up Moore's law and the law of large networks, you should do well. And as we heard earlier with batteries and such coming on, that's great. So let's talk about the objective function. What we said in Switch is we want to build something where the more carbon you reduce, the better you do. So we created a mechanism that awards tokens. And you get more tokens or more value, the more carbon you reduce. How do you do that? Well, if you think about it, everything that generates energy is plugged into the Internet of Things, as are big utilities. If that data got shared, we could award based on how much energy is created. But if you take in other data, you know what people are displacing. So for example, in India, where they burn coal, if you displace carbon dioxide in India, you'd actually get about 7 times more award. This becomes a natural mechanism that actually sends more investment to the global south, which is also the global dirtiest in terms of pollution and needs the help the most. So that's kind of a portion of the mechanism design. So we created what we call a proof of production protocol, a machine that figures all of this out, and then bringing in a network of nodes to go do it. And again, borrowing from Bitcoin, if you want to do mechanism design, how do you do something that essentially guarantees scarcity? In Bitcoin, they do this by you burn a lot of energy solving math problems. This has the corollary effect of the more math you do, the more energy you burn up. So you actually consume energy and emit carbon, and as you know, people have been talking about that. This is a mechanism that's a little bit different. You get rewarded for the more energy you create or carbon that you reduce. And we have this working in Germany and Austria now with about 1.5 gigawatts. If you're building a new mechanism, you don't really want to bring to the world a brand new game. You kind of want to co-opt an existing game. In other words, as you know, something brand new is difficult, but an improvement is good. So we think of this as take an existing game and add a new mechanism and insert it in there so that the players would want it. So it turns out there's about $600 billion in the carbon markets today, and that's valuing carbon at about $20 a ton. As it goes to 50, this whole thing gets more valuable. Here's another interesting thing. There's only about $60 billion a year invested in government credits for renewable energy. And Ethereum, which is one of the best-known coins, is worth about $68 billion right now, which is to say That one thing that's 3 years old is already bigger than the entire government incentive market. And more people get up every morning worried about climate change than how can I build a better smart contract. And that's just a way of saying there's a lot of potential energy here.
Of all the things
Next thing, it's really good to understand pattern recognition here. What you want to do if you're building something like this to get mechanism design right, getting back to what Charmaine said yesterday, is you really want to understand what motivates people today. What's the problem? Well, to do that, one of our U.S. investors is a guy named Steve Jurvetson. And Steve is famous because he was the first money in Tesla, Solar City, and SpaceX. He's probably put more into renewable projects. And I asked Steve, who was great to have as an investor, as he looks at this, what's the problem that he sees that essentially has to get solved? Can we turn the volume up a little bit?
Right, of all the things one could do on the planet, whether you take a very cynical Copenhagen consensus approach or take just a common person's approach to this, how do you know where the most bang for the buck exists? And you see, unfortunately, in some green energy projects, as we saw firsthand in wind, when the incentives get out of whack, you'll have all kinds of wind turbines built in California, for example, that are spinning idle, right? They're not going anywhere. They're not wired to anything because they got their credits for building the capability, not for actually doing something useful. This would naturally accommodate for all that to give you global prioritization. It's almost like being a market maker in a very distributed sense for data streams that were formerly fractured.
So, and part of this is there are all of these things going out there that don't participate in a market, right? And so this is kind of how one builds up a two-sided market and this idea that there's a lot of interest in it. I'll give you another example. I was talking to somebody at Goldman Sachs, and top urban impact investor. They wanted to invest in solar in New Jersey, and the issue was a lot of overhead to go do that, and then the rec market, the actual price of carbon kept fluctuating there, and they were underwater. An interesting thing about a mechanism here is one could say buy tokens in the US or in Norway and then direct them to go to a project, say, in India. And then in India, that would help basically speed up the production of renewable energy, and then it would start also generating or creating value here, and it becomes a frictionless way or kind of an economy to be built up. You also want to encourage a commons or data sharing. So here the question is, how do you get lots of people to share data? And the answer is, you want to return more value to the people who share it with you. It turns out, like in energy, there isn't that much data shared. It's more valuable to know, for example, in the EU, they want to know where did it come from. If you know what time of day it came, you can figure out if it's displacing other energy. So if you share this into a commons, it becomes more valuable. Often when you say the word commons, people think, well, it's not as like value producing as if I own it, but that's not actually what Elinor Ostrom had in mind. So I want to introduce you to John Clippinger, who's a good friend of mine at MIT, a co-founder of this. We wrote a book called From Bitcoin to Burning Man a few years ago, and John worked with Elinor Ostrom, and here's what he says about the commons.
Yeah, I think that when people think about a commons, they think about it in a purely altruistic way, and that people are having to give up something to participate in commons. But actually, a commons is a way of people working together, that the benefit of them working together is better than the benefit of them working independently or alone. But if you can collaborate in the commons, then it creates a net benefit to everybody.
Now, where this really takes off is it turns out you can apply machine learning, a lot of what we talked about, to energy. For example, we heard a lot about batteries today. You want to be able to predict the best outcomes, the best investments. We call this algorithmic governance. It's not that we don't like humans doing governance. It's when you have to make lots of decisions quickly, you would prefer to have a machine help out. Here's an example of that. We built this with a company called Black & Veatch. They build critical infrastructure like Hawaii's grid. Hawaii wanted to go solar. They wanted to go renewable. They put a lot of that in, and they got into a problem. There was so much energy in the middle of the day, the network got overloaded, and of course at night, there are not enough batteries. So the question is, what do you do with those incentives? What's the right mechanism? They ran lots and lots of AI simulations, and what they came up with is, don't incent solar energy. Incent buying electric cars. When you buy electric cars, you're making everyone go get a battery. They don't know they're buying a battery for the grid. They think they're getting a car to go around town. But it turns out if you do that, you balance things out. And now what they said is the most important charging vehicles in this network, especially trucks and buses, have made more room for the grid, and they allowed more rooftops to come in. So being able to run simulations and figure out what to do is amazing. Now they're on target to not only be 100% solar by 2045, but to mostly have electric vehicles, right? So this is the adding of intelligence to exponential technologies, which then can help investors make better decisions, which is the reason you want to create a global mechanism here. Any of these things need to be a movement. Being in the middle of an ICO and putting this together, it became really clear to me that this isn't just a startup. This is more like social media or something that has to take off. Tim Draper, who's another famous VC in this stuff, said, crypto is Kickstarter for social transformation. And we're looking for movements, and the real reason to do all this is to reinvent governance, right? Top-down governance doesn't work. All this lightly connected stuff is a good idea. And so what this made us realize is to do something like this, first it has to be lightweight. Like, what's the least thing you can do that can make lots of actors work together? How do you make it open source so they can all do it? And then have this happen in a decentralized way. So like that AI oracle I described, it happens everywhere with many, many contributions. So often when we think of starting a movement, it's like we're going to get activists or consumers. But here, you really get to create a movement for many actors who you might normally think of as customers. So energy producers get in the act. The C40, software developers should be producing things for it. And as we started, a lot of stuff going on in Europe. I'll give you one example right now. There's a company called E2M in Germany and Austria. They're a very large aggregator of energy. They realize that EU subsidies are going to start going away in 2020. They realize we're all going to have to build our own incentive mechanism. They also realize they have to share data better, and that's the reason they became kind of an early design partner with us. We're operating about 1.5 gigawatts with them in Austria and Germany. So if you think about that, this means this thing starts as we launch next month with about 600,000 households. I didn't have a good picture of 600,000 households in Germany, but Chicago is 1.2 million households, and that's about half of Chicago. So the point is, that's a lot of data coming into a system. Another good example of how this kind of activism works is a pre-blockchain example. How many people here know Charity Water? Okay, Charity Water, an incredibly effective charity. They want to get you to give money to make water show up for people in Africa. Water is a really big problem. The first thing they realized is if you have an intractable problem, like nothing can be done and we're all going to die, or who knows, not interested. They quantified it and told you how much they fix each time. Then, a few years ago, they added GPS and cell phones so they could tell you exactly how well they were doing. And then they added flow meters, so you got real-time data of how the water was doing. So the point here is, if you tell people what you're actually doing, what your impact is, that's amazing. So imagine in a project like this, you're interested in offsets, you buy tokens in one country, you know they're going to show up in another country, you can even get paid back. So this is an example of a mechanism that Scott Harrison put together a few years ago. This kind of thing, together with what blockchain can do, measurable, an impact, and an incentive, can really move things a lot. One way of thinking about this is, okay, a lot of this stuff is particularly good in the developing world. By the way, the reason I bring up the developing world here is that the developed world actually is doing fine with all this stuff. Northern Europe's doing fine. The US is coming along. Most of our new investment is. But most of the carbon comes from the developing world. And at the climate accords, India kind of felt like it kept being blamed as a climate criminal because it had coal. And then they're like, are you going to pay for this stuff? The rest of the world kind of walked away. So incenting stuff in developing countries, reducing friction, that's kind of how you win the game. Bitcoin has a big purpose for the unbanked. I think of this as a solution for the uncarboned markets, because carbon markets, amazingly, only exist in the developed countries. You want it to be a global system. Why? Well, seriously, if there is any problem that's more global than where CO2 goes, we don't know what it is, but we haven't really built a mechanism to do that. So finally, leveraging exponential change. Okay, so if you think about it, the big factors here, as we heard, is cost of solar going down, batteries coming up, carbon going up, and large networks. When you take advantage of things like that, you have a pretty good momentum, and you actually get unexpected things, because as we heard earlier, that's what breakthroughs look like. This week, actually, Australia brought online the world's largest battery. World's largest battery is because sometimes in a power system, if something goes out, you have to fire up the gas generators to make up for it. That burns a lot of carbon. They put in a big battery and it reduced the grid by 90%. Basically, they took care of all of 90% of this stuff. And this is just an example of, if you add these kind of mechanisms to a network and you can keep track of them, you can do very well. Ultimately, energy is going to become more distributed. It's going to be a self-healing peer-to-peer network. It isn't yet. So that's why you want to put in something that can apply to the whole system, but incent the movement, a nudge to where we're going. The whole purpose of all this is if you can shift to the left the conversion to renewables by just a few years, you meet the development goals better. So this is a game. How do you build a game to do that? Well, it has to be a global game. That's the reason that we're imagining something that works as well at the kilowatt level in India as a giant plant here. The more data, the more people who come in, the smarter the thing can be programmed. And that's why it becomes a movement. And that's why I wanted to come here and share with you one approach to the design of a mechanism that can help us accomplish our goals. The word cryptoeconomics is a big word. It turns out you can really reduce it to crypto is about the past, immutably proving with data what happened. Economics is about the future, programming a result that you want. If you put the two together, you can start getting to a better future. So we're here at Katapult 2018 officially celebrating the second Katapult. But actually, I think we're here in 2018 celebrating the 10th anniversary of the future. 10 years since Bitcoin came out, 9 years since Eleanor Ostrom came out, what she did, 11 years since mechanism design. Taken together, those are amazing new tools, which I think can inform companies, investment decisions, the way that we work with the public and private sector, as Eleanor said, polycentricity. To me, that's a very exciting moment, and that's why I had excited to have this privilege to share it with you today as we go beyond the 10th anniversary of the future. Thank you.